Hey guys, I told you I'd make a quick video for your study guide, and let's go over the study guide now, just to make sure you guys have your right answers on the study guides that you guys got the other day. Let's go over these vocabulary terms, and you can make sure you have the right answers for your notes. First, it says how fast an object's moving. We know that is speed. Speed is how fast something goes. An object's speed in a certain direction, that is velocity. So speed and velocity are very much the same thing, but velocity includes direction. Speed is how fast you're going. Velocity, how fast you're going in a certain direction. Next, a change in velocity in a certain amount of time is acceleration. When you change your velocity in some way, you are accelerating. Now, there are 5 types of acceleration that we had talked about before, and we're going to talk about on the study guide as well. Start moving, stop moving, speed up, slow down, and change direction. Those are the 5 types of acceleration. If you are accelerating, you're doing one of those 5 things. Next, the pulling force of Earth is, of course, gravity. The tendency to resist a change in motion is inertia. Remember, inertia is not a force, it's a tendency. It's something that tends to happen. Next, how heavy something is, which is based on Earth's gravity, is weight. Okay, weight is all based on gravity. You weigh a certain amount because of gravity. The fourth one object applies to a second object is called an action. Okay, this has to do with Newton's third law. The second object applies back on the first is reaction. That's Newton's third law talking about action, reaction, action equal and opposite reaction. Next, a push or a pull is a force. Next, pushes or pulls that completely cancel each other out are balanced forces. Pushes or pulls that don't cancel each other out, that aren't canceled completely, are unbalanced forces. Next, a rubbing force that goes against the motion of an object is called friction. It goes against the motion. Like this is friction because it's going against what I'm trying to do. It pulls against it, makes it more difficult. Pushing a piece of furniture across a carpet, and causes friction. A device that makes work easier, that has few or no moving parts, would be a simple machine. A machine is just something that makes work easier. So something that makes work easier with few or no moving parts would be a simple machine, not a complex machine. By the way, the 2 ways that machines make work easier is they change the amount of force needed, or they can change the direction of the force, or both. You know, they make the amount of force that you need to do something less, or they put it in a different direction that's easier to do it. Next, a rubbing force that, I already had this one, a rubbing force that goes against the motion of an object, right? Oh no, I went backwards, sorry. Next one, the turning point of a lever is called a fulcrum. That's like on a seesaw where it turns, that's a fulcrum. The part of a lever that you apply force to is the effort arm. Why effort? Because you put in an effort. The part of a lever that moves an object is the resistance arm, because it is resisting what you're doing. Using a force to move an object a certain distance is called work. Work equals force times distance. So you need a force, and it needs to be applied over a distance. And specifically, it needs to go some way in the direction that you're going. Like if I'm pushing this way, but the object's moving this way, all my pushing is in this direction. If it goes this way, then I'm not doing anything to influence that motion. 0 work is being done on my part. Okay, like if a car is driving this way and I'm pushing it this way, it's not moving this way at all. Even if it goes in an angle, like if it goes in an angle like this and I'm pushing this way, I'm doing some work on the car, maybe not all of it. But if it's going perpendicular at a 90-degree angle and I'm pushing this way and it's going this way, it's not being influenced by me at all. So it has to be moving in the direction that at least somewhat in the direction that I'm pushing. And the last one, a special kind of acceleration that means to slow down. Remember, deceleration is not the opposite of acceleration. It's a type of acceleration that means to slow down. Be able to tell what different types of activities are work or not. I'm going to list out activities, and you're going to tell me whether they work or not. Remember, the key is, are they moving? It doesn't matter how hard they are or how easy they are they moving? Next, understand unbalanced forces. That means you have to understand that unbalanced forces lead to accelerations. If you have something that is 25 pounds going this way and 20 pounds going this way, you're going to have a net force of 5 pounds. 25 minus 5 is the opposite direction. If they're in the same direction, they would add up. 10 and 12, let's say. 10 and 12 would be a total of 22 in that direction. But if I have 20 and 25, that would be a total of 5 in this direction, whatever I said. And that would be an unbalanced force, so there would be an acceleration caused. Know all three of Newton's laws of motion and Newton's law of gravitation. So these are the 4 Newton's laws that we learned. 3 about motion and 1 about gravitation. First one, ready? An object at rest will remain at rest, and an object in motion will remain in motion in a straight line at a constant speed. Okay, as long as there are no net forces, like I just described a minute ago. That's the first one. Second one, A equals F divided by M. Acceleration is equal to the force divided by mass. Or if you apply a force to an object and divide it by whatever the mass is of that object, you will get an acceleration. Or you can find the acceleration by taking the force that you applied on the object and dividing it by the mass that the object has. Basically, A equals F over M. Acceleration equals force divided by mass. Third law, Newton's third law. For every action, there's an equal and opposite reaction, meaning when you apply a force to something, the action, there is the same amount of force back on you, the reaction. Forces come in pairs. Last one, Newton's law of gravitation is saying it's that F equals G M1 M2 divided by R squared. With that equation, it was a tricky equation. What that's basically saying is when the mass of an object gets bigger, the force of gravity gets bigger. When the distance, which is the bottom R squared, but when the distance gets bigger, the force gets smaller. So again, Newton's law of universal gravitation, it's saying 2 objects have a gravity to one another. The more the mass, the more the gravity. The more the distance, the less the gravity. So like farther away you get, the less gravity works. Be able to label each of the 6 types of simple machines. Okay, I'm going to have a picture of them, and you'll have to be able to label each one, which one's a lever, which one's a wheel and axle, which one's a pulley. Be able to explain why 2 balls of different weights that are dropped would hit the ground at the same time. This is an important one. If you drop a bowling ball and a golf ball, you might think that the bowling ball would hit the ground first because it's the heaviest. It will not. Why? Because the only thing that affects the way things fall is gravity. Gravity affects all things the same. Okay? I can give you an example of this. Okay, really quick. Ready? Okay, so you can see all things are affected by gravity the same way. The only thing that can affect it otherwise is air resistance. Watch. Okay, I have this and I have this. You're going to see that the marker falls faster than the paper. Watch. Okay, obviously, bring it even higher. The marker fell faster, right? Okay, understand? That's because of air resistance. However, if I take away air resistance by crumpling this paper up, so it doesn't, get stopped by the air particles as much, it still weighs the same. It's still as light as a little piece of paper. Watch. They fall the same speed. Okay? They both fell at the same speed, right? That's because weight does not matter. Mass does not matter. All that matters is the pull of gravity on them once you take out air resistance. And so that's why objects with different weights will fall at the same rate. Next, be able to explain why a feather falls slower than a bowling ball on Earth, but not on the moon. As you just saw when I had the piece of paper, it fell slower because of air resistance, right? Air resistance, the air particles held that piece of paper back a little bit, so it fell. A feather would fall slower than a bowling ball because the feather has a lot more air resistance. The bowling ball basically has none. However, on the moon, that would not happen. Why would that not happen on the moon? There's no air on the moon, so there's no air resistance. All it is just gravity, and there's no air resistance, so a feather would fall the same speed as a bowling ball. Next, be able to label the 5 types of acceleration. They are start moving, stop moving, speed up, slow down, change direction. This is the one people always have trouble on and forget about. Those are the 5 types of acceleration. Okay? If it does one of those things, it is accelerating. Next, know what two things affect the force of gravity on an object. The two things, as you can see, as you saw in that equation, was F equals, and then the gravitational constant, and then mass times the mass divided by the distance squared. It is mass and distance. Those are the only two things that affect the force of gravity in an object, for mass and distance. Mass is the greater the mass, the more gravity. Distance is the greater the distance, the less the gravity is. Next, note the two ways that simple machines make work easier. I already mentioned this one. They change the direction, they change the amount of the force, or they change the direction of the force, or both. Know the difference between speed and velocity. I mentioned this one too. Speed is how fast you're going. Velocity is how fast you're going with direction, in a certain direction. And then last two. These ones are math ones. These are like physics math ones. Be able to calculate speed when I give you a distance and a time. Speed is just distance divided by time. You can hear that when you say, I'm going 50 miles per hour. The word per means divided by. Miles per hour. Miles divided by hours. What is miles? A distance. What is hours? A unit of time. Miles divided by hours. So I'm going to give you something. Your example here is going 6 miles in 2 hours. Well, it's distance divided by time. Which is the distance? 6 miles. 6 divided by what is the time? 2. 6 divided by 2 equals 3. That's your speed. 6 divided by 2 is 3. If I said going 10 miles in 2 hours, 10 divided by 2 equals 5. If I'm going 9 miles in 3 hours, 9 divided by 3 is 3. Okay. If I'm going, but listen, if I'm going, 10 yards in 5 seconds, 10 divided by 5 equals 2, but it's 2 yards per second. It's always the distance per the time. Okay. Next one, calculate acceleration when given the force and mass. This is the same thing. A equals F over m. That's Newton's second law. Acceleration was force divided by mass. I have an example here. Force equals 10 newtons. Mass equals 5. 10 divided by 5 equals 2 newton. 2 meters per second squared. So that's basically what you need to do with those ones. You need to know it's distance divided by time and it's force divided by mass. Okay? That's it.